All right, this is section 1.5, exploring angle pairs. So let's start with a quick vocabulary check or review. So let's use a word from the list below to complete each sentence. Use each word just once. So we have interior, rays, and vertex. The blank of an angle is the region containing all points between the two sides. Well, that must be the inside, also known as the interior. When you use 3 points to name an angle, the blank must go in the middle. The vertex must go in the middle. Okay. The sides of angle QRS are blank RS and RQ. Rays make up the sides of an angle. Okay. So let's define the following. So we have S, RV is bigger than 90, so therefore this is obtuse. TRS is a small thing. This is acute. TRQ looks to be a right angle. VRQ is a straight line, so this is a straight angle. Okay. New vocabulary for this section, conclusion. So another word for conclusion is conclude. A conclusion is the end of an event or the last step in a reasoning process. So let's complete each sentence with either the word conclude or conclusion. So conclude is the verb, conclusion is the noun. So if it rains, you can blank that soccer practice will be canceled. Well, I can do something. What can I do? I can conclude. All right, number 9, the last step of the proof is the conclusion. So I'm referring to something. This is the noun. Okay. All right, types of angle pairs. So these are big vocabulary words that we really need to know big time. So all 4 of these, I'll do these. Adjacent angles are 2 coplanar angles with a common side, a common vertex, and no common interior points. Vertical angles are 2 angles whose sides are opposite rays. Complementary angles are 2 angles whose measures have a sum of 90. And supplementary angles are 2 angles who have measures that have a sum of 180. So here's a picture, and let's see if we can draw the word with the angle pair relationships. So which angles are supplementary? Which ones will add up to be 180 degrees? Well, if 3 is 90 degrees, we need another 90-degree angle. How about 6? So angles 3 and 6 add up to be 180 degrees. Which angles are adjacent to one another, next to one another? 2 and 3 work. Those are adjacent. Which ones are vertical? Which ones are across? 2 and 5 are vertical angles. They're across from one another. And which ones add up to be 90? Well, it looks like 1 and 2 work. 4 and 5 would also work, but the one choice I have is 1 and 2. All right. So let's use this diagram on the right. Are AFE and CFD vertical angles and explain? Well, let's use these words to determine that. So the rays of AFE and are FE and FA. The rays of CFD are FC and FD. So FE and blank are opposite rays. FE and FC are opposite rays. FA and FD would be opposite rays. Are AFE and CFD vertical angles? Yes, because AFE and CFD share, follow the definition. Okay, problem number 2. All right, so can we conclude that TW is congruent to WB? Line segment TW is congruent to line segment WD from the diagram. Let's explain. So first, let's circle items marked as congruent in the diagram. So TW and WV are marked as congruent. These two things are marked as congruent. That's what those markings represent. Can I conclude they're congruent? Yep. So the congruence marks are on line segment DW and line segment WB. Okay. 1-9, postulate 1-9, the linear pair postulate. So if two angles form a linear pair, then they are supplementary. So if angle A and angle B form a linear pair, then measure of angle A plus the measure of angle B must equal 180 degrees. Supplementary means to be 180 degrees. All right. So let's do this here. So we have angle KPL and JPL are a linear pair. We give the measurements of both of these angles. How can I check if these measurements are correct? So what is one way to check the solutions? Place a check if the response is correct. Draw a new diagram. If it looks good, solution is correct. No, pictures never are a satisfactory way to prove anything in geometry class. How about substitute the solutions into the original problem statement? Yep, that would work. Okay, so let's check it. So the measure of angle KPL is supposed to equal 24. Measure of KPL is given to us as 2x plus 24. Does that equal 64? Okay, so if I subtract 24 from both sides, I get 2x equals 40. And I divide by 2, I get x equals 20. All right. Now let's check this other one. Measure of angle JPL equals 116. So I have 4x plus 36 equals 116. And I subtract 36 from both sides. So I have 4x equals 80. And I divide by 4, I have x equals 20. So I get the same value for x. That looks good. Okay. So you solved correctly because we found the same solution to both equations. I think I spelled that word wrong. Let me fix that real quick. Okay. All right. So let's try a problem. Let's fill in the steps to each one of these. All right, if I know that Km bisects an angle, and I know JKL equals 72, what is the value of this value? Okay, so if I know something bisects something else, then it makes true congruent statements. So this is called the definition of angle bisector. All right, now, what is JKM? What is MKL? So if I add both of those together, I'm going to get the whole. So this is called the angle addition postulate. Okay, now, since I already know these two things are equal, one of them is twice the measure of both of them, isn't it? So this is called the substitution method. Now, dividing, I get half. Okay, so there we go. So therefore, if I know that this value of JKL is 72, then what's half of that? 36. All right, so now let's complete this picture here. So this is JKL. All right, line MK, or ray KM bisects it, and both sides equal 36. Okay. So let's suppose that our friend calculated x by doing the following. So 4x plus 2x equals 180. They solved it to get x equals 30. Well, what went wrong here? Let's see what happened. So the best description of the angle on the right is that this is a right angle. So 4x plus 2x should equal 90 degrees. So what was the error? So my friend thought, so she thought, a right angle measures 180 degrees. So she set the sum of the angle measures equal to 180 degrees. All right, and that is the end of section 1.5.